Hey everybody, this is Mr. Walsh, and today we are going to talk about the vocabulary of the periodic table. And what I mean by the vocabulary of the periodic table is we need to understand what words we use to describe the parts and the locations of the elements on the periodic table. In order for us to get a handle on how the periodic table is organized, we first have to kind of understand the words that we use to describe it. And so while this is probably the longest presentation we have by slides, it's not going to be the longest video, I don't think. But let's get going here. Okay, so groups are the columns that go up and down. And notice they are numbered here. 1, 2, all the way over to 18. Okay, so the columns go up and down. In every part of the periodic table, except for the elements that are down here, are part of a group. Okay. Now, we also have another name for the columns, and these are called families. And families, instead of being numbered, are named. Okay. So all of these columns have names going across here. Okay. So not only are they named by family, but they're also numbered using groups. And that is what the difference is. The only difference between groups and families is that groups are numbered, and families have names. Okay, and when we get to the end of this, you'll see the thing. So you'll see you'll see some of the names of the elements. You probably would love to have this sheet out, and you can pause the video to get down these definitions so that we all kind of know and have the familiarity of what's going on with these vocabulary terms. Okay? Okay. So if the columns are named and numbered, periods are the rows going this way, and you can see that here they're numbered 1 through 7. Okay, so what this does is it sets up a grid, okay, where you have numbers going across this way, 3, 4, all the way up to 18, and then you have periods going down, and so you can basically find any element by using a group number and period number anywhere you want on the periodic table. Okay, so what element is found in group 2, period 3? So we come over here to the periodic table. So group 2, okay, that's this column. Okay, this is numbered here. Group 2, period 3. So 1, 2, 3. That's going to be magnesium. Okay, magnesium is in group 2, period 3. Okay. Now, in this case, I didn't ask you what the symbol of the element was or what the name of the element was, so I just asked you for the element, so either the name or the symbol would be fine. Okay, so now group 16, period 4. Okay, here's our periodic table. So group 16. Now, this is, I don't mean this to be tricky, but a lot of people forget that this is a period here. So we want to go 1, 2, 3, 4, group 16, and so that answer is Se, or selenium. Okay, put the periodic table back up top here. Okay, so let's go through this here. Okay, blocks. Blocks are big parts of the periodic table. So there's 4 blocks on the periodic table. There's this one here. Okay, and that's the S block. Okay, then there's this one over here. Okay, that's the P. So this is S, this is P. And then there's this one in the middle, which is the D. And then this is the F block here. Okay, and these blocks are based upon the arrangement of electrons, which we call electron configuration. Okay. And more on that soon. We haven't gotten to that, but it'll make sense when we go over it. And so we have because of the arrangement of electrons, we end up having 4 distinct regions on the periodic table. The S block, the P block, the D block, F block. Okay, and so the S block, if we were going to do this, the S block we could say is the what do I want to say? The far left part of the periodic table. It's also group 1 and 2. The D block is the far right part of the periodic table, and it's group 13 through 18. Okay, the D block is the middle of the periodic table, and it's groups 3 through 12. And the F block down here, these are the elements below the periodic table, and they don't have a group number. Okay, so that's kind of how we do that. And again, it's arranged all by the definition of the blocks is that they're the parts of the periodic table based on its electron configuration. This is a configuration. Okay, so those are the 4 blocks. Okay. Then another way we divide up the periodic table is with this guy. This is what we call, looks like a set of stairs, so we call that the stair step. And so what it is it's a division, and I would say half, but it's not half. But it divides the periodic table into 2 distinct sections. And so this side is our metals, and this side is non-metals. Okay. And so the stair steps separate the periodic table into metals and nonmetals, and then the thing that's kind of like a metal, but also kind of like a nonmetal, are things called metalloids, and the metalloids kind of touch the stair step. Okay, more on that now. The metals are everything here. Okay, so kind of below the stair step, including this one, believe it or not. Okay, and these down here. Okay, these are all metals. And so the metals are the elements that are to the left of the stair step. Okay, or if you're looking at the stair step, okay, you could say under the stair step, right? If people walk up the stairs on this side, they're under the stairs. Okay, and the nonmetals, these are on this side. This is the lighter stuff, okay? The lighter colored things here. And the metals, or the nonmetals, are to the right of the periodic table. And the exception here is this element, hydrogen. Hydrogen we're going to put into being a non-metal, okay? There's some argument in chemistry about whether hydrogen is a metal or a non-metal. But for the purposes of this class, we're just going to put hydrogen as a non-metal. Okay. Sometimes people put hydrogen here. I have a couple of periodic tables where you're going to see hydrogen there. Okay. And then lastly, the metalloids, and I'll X them here, are the ones that touch the stair step. Okay. And they are kind of like metals and kind of like nonmetals in their properties. But let's see here. Aluminum here, Al, that's a metal. We're always going to consider aluminum a metal, even though it touches the stair step. Okay, so we have 2 exceptions to this grouping. We have hydrogen, which is always a nonmetal, and we have aluminum, which is always a metal. Okay, now this is a weird periodic table. I don't know why there's a printed periodic table that did this. This is all shifted. This should be up 1. But not unfortunately. Fortunately, it doesn't change what we have here. But we're looking at the main group elements. Okay, so the main group, and a complete synonym of main group elements is representative elements. And the main group elements are here, this side. This is my only Lord of the Rings reference. It's like the 2 towers here. Okay, so this is the 2 towers we have. So this is the S block, okay, this is the S block and the P block, if that's what you want to say. Okay, or you could say groups 1 and 2 and 13 through 18 if you wanted to do. But those are the main group elements, the elements that are sticking up above the middle of the periodic table. Okay. The transition metals, again with this weird periodic table, are these in here. These are the transition metals. So the middle, this is the middle of the periodic table, or groups 3 through 12, or you could say that they're the D block elements are transition metals. And then the inner transition metals are below the periodic table. Okay, we're not going to deal too much with the ones below the periodic table, but you have to know that they exist. And there's two rows of the inner transition metals. Okay, and again, these are the F block elements. Okay, and there's 2 rows of those guys. Okay. So in the F block, okay, or in the inner transition metals, this top row has a specific name, and it's called the lanthanide series. Okay, so it's the top row of elements found in the inner transition metals. Okay, these are called the lanthanides because lanthanum here is kind of the trigger for how we know to go down here. Like if you look at the periodic table, you go cesium, barium, lanthanum, element 57. And if you keep going straight, you end up with element 72. So you can't go 57 to 72. So you have to go 57 and then down here to 58, 59, all the way over to 71. So lanthanum is that element that kind of triggers us to know to go down here. So that's the lanthanide series, or sometimes they're called the lanthanides or just the lanthanoids. Depends on how you were taught and who taught you and where you were taught and all this stuff. Okay. So similarly, the actinides are the bottom row of the periodic table. Okay, they're part of the inner transition metals, the F block. And again, if we're looking at the periodic table, actinium is the kind of the trigger to let us know that we go down to do the bottom row. So we have francium 87, radium 88, actinium. So if we're going to have actinium, we know we go down to the actinide series. So, okay, that's where its name comes from. Okay, and just like the lanthanides, they can be called the actinides or sometimes the actinoids. Okay, so families, remember these are the names. These are the named elements here, or these are the named groups. Okay, they share chemical and physical properties. When Mendeleev started organizing his periodic table, okay, he did so by arranging elements with the same chemical and physical properties. Okay, and so he put all of those together. So let's start with one, and then we'll talk a little bit about it. Okay, so the alkali metals, that's this group right here. And again, hydrogen, I'm going to exclude hydrogen from the alkali metals. That's not an alkali metal. Okay, the alkali metals are lithium all the way down to francium here on the periodic table. Okay, and how do we know that these are grouped together? Well, one of their chemical properties is that they react with water. And we're going to be doing a lab that has these guys reacting with water like big time. Okay, so it's going to be fun to see and fun to do. Okay, but hydrogen, because it's special, again, we're counting it as a non-metal, so we're just going to put it somewhere else. Okay, so these are the alkali metals, and right next door here we call these the alkaline earth metals. Okay, so it's kind of funny that the alkaline earth metals, which is group 2, okay, are next door. So it's like these two groups, again, without hydrogen. Okay, these are the alkaline earth metals, and these are the alkali metals. So kind of the pair go together by name, and they're paired by where they are in the periodic table. And both of these are part of the S block. So they have a lot of similarities. Okay, that's one of the things about the periodic table that's really neat. But alkaline earth metals are characterized because when they're mixed with water, these guys turn to bases. They become slippery and things like that. So the alkaline earth metals are beryllium down to radium. Now, one that you probably never would guess what the name is, okay, or where it is, okay, the boron family. This is group 13, and the boron family here that I have outlined, okay, these are starting with boron and go all the way down to thallium, okay, and so kind of like this over here, if we have where the names are similar being next to each other. Here, if the names are similar, well, guess what the next door one is? So group 14 is called the carbon family, okay? And they go from carbon down to lead, okay? Well, there's other element below lead, but these are man-made elements, so we don't really use those very often, okay? But group 14 is the carbon family, okay? So we have kind of a pair here and a pair here. And now we're going to have triplets, okay? I'll show you what I mean by that, okay? Next door is the nitrogen family, group 15, okay, right here. Whoop, whoop. But the nitrogen family is also called the pnictogens. The P is silent. Pnictogens, okay? And so that's a fun name. I like the name pnictogen. Okay, pnictogen. And then next to the pnictogen, okay, is the oxygen family, but that also has a funny name. Okay, here's this. So it has a funny name. It's called the chalcogens. Okay, so these guys are the chalcogens. And this is group 16, okay? And then next to that is the last one of the bunch, and this one people know more than any of them. This is called the halogens, okay? The last not the last group, but the second to last group is group 17, is called the halogens. Okay, so we have Gen X, Gen Y is Gen Z. I don't know. Okay, but we have pnictogens, chalcogens, halogens. Okay, and then make sure I get them all. The last one here, the last family is this one. This one is the noble gas family, and they share similar properties and traits. The noble gases, they do not react with, they're inert. Okay, the noble gases are inert. They don't react. That's why they're noble. Okay, they don't lower themselves to do anything with all the other elements on the periodic table. Okay, so they are noble here. Okay, that's my little crown showing how noble they are. Okay, so I will post this in the Google Classroom so you know where each family is and what we call how we divide the periodic table in parts here. So we have the alkaline, again, notice pair, we have a pair that's similar, then we have triplets, and then we have the standalone because they do their own thing. All of these guys are called the transition metals. We don't separate out each part of them, but I will say that, there are certain sections, like this section of the period of the transition metals has a special name. Okay, those are called the coinage metals or whatever. But the point is that all of these elements from here to here are called the transition metals, and all of these guys are called the intertransition metals, and then we divide this up into a little bit. We have the lanthanides and the actinides. Okay, I'll post that slide in the Google Classroom. Okay, so what we're going to do is use vocabulary, all this new vocabulary, to completely describe nickel. Okay, so nickel is here. Okay, so that's going to be in, look, group 10, but it's 1, 2, 3, 4. So period 4, group 10. It's a transition metal. It's also just a metal because it's under the stair step, right? Okay. Here's the stair step. All periodic tables have that stair step. And then it's, let's see, what else do we want to say? It's part of the D block. Okay. So the point, that's a lowercase d, sorry. It's the point is that there's a lot of ways that we can describe elements on the periodic table. Okay, we have a lot of words that do this, and depending on the case, depending on how we're using it, we could be saying that it's a transition metal, or maybe all we care about is the electron configuration. We say that it's a D block element. So those things happen. So how we refer to it is based on what the usage is. Okay, so chlorine. Chlorine is here. Okay, so this is group 17, period 3. So group 17, period 3. It's also a non-metal. It's above the stair step, right? Let's see. It's in this group 17, which is a halogen. Halogen, it's part of the P block. Okay. You could say it's a main group element, or you could say it's part of the representative elements. Okay, so there, like I said, there's a million ways that we can describe these elements, and we use the one that is appropriate for the topic in order to describe them. Okay, let's see. And the last one, let's see, uranium. Okay, you know my joke about uranium, right? So, anyways, it's down here. Okay, so uranium is an inner transition metal. Okay, we really don't have a group number or a period number for this, but it's also part of the actinides. Okay, it's a F block element. So, like I said, we could even go back to how we were describing it before we knew all this stuff in the periodic table. It has an atomic number. What does it say? Element number. Atomic number of 92. That's another way that we describe it, right? So, like I said, a million ways to talk about this that all depend on how we are using the element. Okay, there's a point at which we may care about it being an F block. Sometimes we don't care about it being an F block. We only care about it being an intertransition metal. Okay, if we're talking about elements getting made in supernova, maybe we only care about the fact that its atomic number is 92. Okay, so just case by case. This is why we use all the vocabulary, and that's why we need to know all the vocabulary so that we can, if somebody talks about an element with atomic number 92, we know it's uranium. Or if we're talking about F block elements, we know that it's going to be the elements around uranium. Okay, and those elements all have similar properties. That's the periodic law. Okay, elements have similar properties. They are grouped on the periodic table by similar properties. Okay, so there you have it, everybody. The vocab of the periodic table.